Hi, today we will talk about standardization and European legislation, about the law in the European Union which tells you what you should do or what you shouldn't do regarding the electronic components, electronic parts, electronic appliances, everything that is sold in the European market, and therefore it has to comply to certain rules. And as an electrical engineer, when you design electronic products, you should be aware that there are several restrictions on that area and that you should know them in order to be able to produce, to design electronic products that will be able to be sold in the European market without problems. And today's lecture will be a little bit more on the boring side. I hope I will be able to make it interesting also for you. All right, so let's start with standardization and legislation. Regarding standards, you probably all know that if we obeyed the standards or we had them worldwide from beginning of electrical industry revolution, we wouldn't have now so many different sockets. So yeah, standards are important, and they are documents that agree on some technical specifications and other criteria, following rules, guidelines, definitions, characteristics, development materials, products and services, so that anyone in the world is able to make devices that are safe, protecting environment. They are simple to produce, they are efficient, they are assuring high quality, they are compatible with each other, and they can be traded everywhere in the world and are compatible between each other, also in terms of communication. Let's go a little bit into history. So the first thing that was standardized back in 1789, it's A4 paper. Later, it was the meter that was defined as a 1/40th millionth of circumference of the Earth. The problem of the measuring units was at that time that every country had its own measurement units, which were made according to the king. So the king was the standard of the country. So the king thumb, the king foot, the king whatever yard was the standardized measurement unit. And when the king was, replaced, then the units changed. So they wanted to make some unit that was common to all people in the earth. And the only thing that is actually common to all people is the earth itself. So they measured the meridian of the earth, and then they calculated the circumsolar that thing of the earth and divided by 40 million, and we got meter. The first standardization organization was Electrotechnical Commission, International Electrotechnical Commission, IEC, back in 1906, and electrical field of electrical engineering was the first to be standardized on the basis of a common organization. Later, much later, after Second World War, the International Standardization Organization was formed, which actually was covering all the rest. So electrical engineering was the first to be standardized, which is quite normal because, it was a driving force for the Industrial Revolution at the beginning of the 20th century. We have many standards. Standards are covering different fields. We have fundamental standards, which basically tell what is what. So it defines the meaning of words, the meaning of fields, the general definition, so that when we speak about a thing, that we all know what that means. The terminology standard is even more in detail defining the terminology in a certain field. Then we have test methods and analysis standards. For example, we want to know how to test something, some product, if it complies with the standard. Then we have specification standards, which defines the characteristics of product, and also organization standards, which defines how to organize some company or quality management of testing facilities and so on. So more or less, these are the basic standards types. Now about the levels. The standardization goes from international to regional, national, down to industry and internal. So what does it mean? International standards are worldwide. Regionals are for Europe, America, Asia, for example, or Australia and so on. National standards are for each country, Slovenian, German, whatever. Industry standards within some industry field, like, for example, automotive standards, medical standards. And internal are internal standards in a company. Looking from how the standards are specialized, they are getting, of course, they are more broad on international level and getting really specialized within the companies. Regarding the strictness, these are the most strict standards and these are the most general. So that's quite important to know that inside the industry, always they are stricting the rules. They are not making them more vague because they want to strive to be better than the others. And also, they have to comply to the, let's say, regional standard. In European Union, you have to comply to regional standards in EU. While national-wise, you can be better. In the industry market, even better. Internally, within the field of that industry, even better. So, for example, car industry has much harsher standards than general electronic industry in the region. But internally, in, let's say, I don't know, Volkswagen, let's say, for example, they could have even more strict standards to be better than the rest. Well, that's debatable, of course. About organizations, internationally wise, we have International Electrotechnical Commission. We have ISO, International Organization for Standardization, and we have ITU, International Telecommunication Union. All three are based in Geneva, in Switzerland. This is covering everything except electrotechnics and telecommunications. That's it. In America, we have similarly similar standards institutes like ANSI and Electronic Component Association and IEEE, and many others as well. But we are more focused in Europe. In Europe, we have a very similar scheme as internationally. We have SIN, we have SINELIC, and we have ETSI. And they sort of are vertically connected. So if we go into this picture here, we have ISO, which is actually connected to CEN. We have IEC, which is directly related to SINELIC, and we have ITU related to ETSI. So all the standards general go in that direction. The electrotechnical standards are here, and here are the telecommunication standards. So the governing institution in Europe is CEN, and that one is directly connected with European Commission. So the European Commission is the one which issues the law, the directives that says you should do this and this and you shouldn't do that and that. And in standardization organizations, they are preparing standards that are supporting that. So if the EU law says you shouldn't make electrical device that will kill someone by accident, then you should be able to know how to make that. And this is written in standards. That's it. Now, in the national level, we have each country has its own standardization organization, which actually more or less copies the standards from EU, which are harmonized or let's say connected with worldwide standards here. And the industry users and other organizations are then using these standards for the product development. So in Slovenia, we have SIST, Slovenian Institute for Standardization, which is preparing their own standards or adopting the international standards. They are representing the interests of Slovenia in these international and European organizations. And each standard has several levels. So it has sort of life cycle. So we first start with the and I will try to now switch to this here. Yeah. So in standards, we first start with the draft. So here. This is the draft, which means it's just a proposal or working draft. So this is working draft. Then we continue with the draft, osnutek, osist. It's the draft. Then they vote for that draft. It goes around in this all standardization organization in EU, for example. Every national organization is then checking it and voting whether it's okay or we should change something. And then we continue in the final draft. Končni osnutek. Final draft. Let's say is F this. Final draft, international standard. This is draft, international standard. And this final draft then more or less is just a little bit polished in terms of grammar and minor changes, and then it is issued as the Slovenian standard or the international standard, if you want. So every standard has then its sort of period when it's valid, and that is 5 years. And after 5 years, it is revised. After 5 years, well, you can prolong it, change it, or cancel. Depends whether it's still useful. And that's why standards have also the year number next to them, so that we know which version we are talking about. Do we talk about the old one or the newest one? So each standard has to be also equipped with the number denoting the year in which it was issued or changed or similar. Okay. So these are some examples of Slovenian standard. So the national standard is called SIST. The transposed international standards is transposed from the IEC CES IEC number and year, or European standards can be transposed to Slovenian CES EN and so on, or some national standards like CES DIN from Germany. So this is how the standards in Slovenia look like. Most of them are transposed from international or European standards, but some of them, which are specific to Slovenia, can be found here. All right, then what do standards actually specify? How is the conformity to standards of product made in European Union? Well, standards are telling you what are the technical specifications of the electronic devices you're selling, how to achieve them, and how to test whether they are compliant with them. And legal part is telling you which standards are to be complied with. So the European directives will tell you this is the list of standards you should comply. And in old times, before 1985, that was more or less dependent on the country and the region. So in European Union, back then, each country had its own legislation, own set of standards, own set of rules. And if you want to sell to these countries, you had to comply to all of them. So that was quite a problem. And actually, back then, it was quite hard when the number of electronic devices increased really rapidly. It was quite hard to follow all that and to be able to sell worldwide, since you had to check each country separately and try to comply with its rules. So that's why they started with the new approach. The new approach was that all the legislation, the legal part was just kept on the essential level. Everything else was left to standards. So, to say in different words, and in this new approach, it's not a new one, it's from 1985. The legislation just tells you, the directives tell you that you should comply with minimum basic requirements regarding safety, health, environment protection, and these are defined by the legal part in the European Union. All the rest is shown in standards. So you can be even smarter than that and make design without checking the standards if you can, but usually it's easier just to follow the standards. So the standards are just recommendations how to get these specifications you need. For example, if the law says that your device should not be harmful to you due to electrical shock, well, you can achieve that by keeping the distance between the high voltage parts and the case, and between the high and low voltage parts on the PCB. Well, they say, okay, you should have a distance of 3 millimeters or 6 millimeters and so on. And they will check that with measuring the actual distance. But you can do it in different ways if you want. But it depends whether it will be as good as that, or actually are you able to achieve that without actually following these rules which are written in standards. Yeah. Maybe it would be much expensive to use some special, technique to avoid these distances, let's say. like filling with some dielectric or something. So nevertheless, I wanted just to tell you that standards are not the final word. They are developing, following the development of the technology, and they are changing all the time. And you, as a product developer, it is the easiest for you to follow these standards, and just if you do follow them, then you are more or less on the safe side. This new approach was based on the free movement of goods in European market, and they say if you want to sell a product in European Union, then you have to label the device by CE mark. Without that, you are not allowed to sell. And affixing this CE mark is the sole manufacturer's responsibility. And by affixing that CE mark, you state legally that you, as a producer, as a manufacturer, you have the whole responsibility for the conformity of the product. This is the new approach. And harmonized European standards are a special part of the standardization system that are developed by the request of European Commission to support European directives in this area. So let me tell you a little bit more, or in different ways. Not everything in European Union has a CE mark or needs a CE mark. If you look around, you can check that most of the things actually don't have it. But those who are obliged to, you are not allowed to sell without it. Let me check that pencil here does not have a CE mark because it's just a pencil. You can harm someone with it, but that would be unintentional use of that pencil. Therefore, if it's not an electronic device, or maybe it doesn't fall into some other areas like children toys, for example, also are or building products, construction building products, and others like many I will show you. If it doesn't fall into that areas, then it doesn't need a CE mark. I don't know, let me check that pen here also doesn't have a CE mark because it's not a toy. It's a pen. I don't know what else. That USB key here needs a CE mark because it can be harmful. How? It can radiate electromagnetic noise, and therefore it needs a CE mark. And then another thing, if the component you're selling is not intended for end user, like you cannot buy it in Interspar or Hofer or over the internet everywhere, then it's also not obliged to wear CE mark. For example, a microcontroller, a chip, it's a sophisticated electronic device, but it doesn't have a CE mark on it because it's not intended for end user. Is it intended for a specialized, well-trained, as we are, electrical engineer to put it into a final device? So this is what you should be aware of, that these are the fields. There are different fields in which some of the products need CE mark and the other don't. We'll go back to that in a few minutes. Let me just show you a little bit more about these field. For example, what is a notified body? A notified body is an organization which is certified to measure and assess the conformity of devices. So it's like a laboratory, which is the only laboratory in a country or in an area which is certified to assess whether something is compliant with the law or something is not. And in this information database, you can get the list of all notified body institutions. And in Slovenia, this is SIQ. What are harmonized European standards? Harmonized European standards are those standards which are developed in the European Standardization Organization, CEN, and are ordered, or how to say, synchronized with the European Commission. So if the European Commission says, okay, for a CE mark, I will now include this and this and this to be essential or to be obligatory to wear the CE mark, then the CEN should develop standards for it, and this will be harmonized standards. So harmonized standards are defining all the properties and also the measurement and all the rest that it's needed for the European goods that are obligated to be equipped with CE mark. And if you are, as a producer, if you are following these rules, if you're following all the harmonized standards that are applicable to your product, then it's not necessary that your product is actually compliant. But if you follow these standards, a presumption is valid that this equipment you're producing is actually compliant with the directive, with the standards, with the law. So only, I would say, there is a high chance that it is so, but it's not necessary so, which means that you still have to measure the conformity of your device in a laboratory, in a notified body laboratory or your own. That's also possible. Depends on which type of device we're talking about. So the conformity assessment, it's never the responsibility of the notified body, which is also important, because if you get a certificate from SIQ, for example, if you get a certificate from SIQ and they tell, okay, your product is perfect, it's great, who is then responsible for that other 10,000 products you are producing next year? It's not SIQ, it's you. It's the company, the producer, the manufacturer. So you got a certificate for a single product, not for the other 100,000. So the CE mark is then attached to the device, to the product by a manufacturer. And by the CE mark, the manufacturer is legally stating that it is whole responsibility, the sole responsibility of the manufacturer for the compliance of that product. And talking about safety, health, and so on. The CE mark is defined very strictly, geometrically, regarding also the ratio, sizes, and so on. and it should be affixed to the device, to the appliance, before it is put to the market, not after. Which means that if you are putting your device, your product into market, you should affix it with the CE label, and then you send it to the shop. There is the seller is not later obliged to put the CE marks on the product. It's even not allowed. And what should be on the apparatus? So you should put the product type, number, trade name, address, and safety information, and CE mark. All that in such a way that it is not easily removable. The CE mark should be a part of that nameplate, not just a sticker you put somewhere extra. It should be a part of the nameplate. And also, if the product is of such shape that it cannot have a label on it, like a mobile phone, for example. Even on the backside now, there are so many things, and they should look sleek and smooth, so no labels are more or less printed there. So then it should be accompanied by documents including all that. And you should have, or you should add, instructions in local language, which is quite funny sometimes. Google Translate rules, I must say. Now, this is how the compliant power supply looks like. So it has a lot of information on that. The name of the manufacturer, the trade names, which company, what is the type, and then some electrical data, the instructions how to, or what are the connectors, the safety instructions, serial numbers, and a lot of marks. The only mark that is actually important for EU is the CE mark and nothing else. All the rest is maybe for other regions, or are just some quality marks that are showing off. Hey, we are the best if we did the TÜV Rheinland or TÜV Süd or Geprüfsicherheit or similar. And this is how non-compliant product looks like. You see that it still has some basic data, and but the CE mark is a little bit suspiciously strange, and others as well. And if you look how this power supply is made, it is certainly very dangerous, because there is no isolation between the high voltage parts and the case, and the case is metallic, and it has only cable with 2 wires, so it's not grounded, so it is deadly dangerous. And the producer intentionally did not mark it with the correct CE mark, because actually if he put a correct CE mark on it, then he would state his whole responsibility for the safety of this product. So if somebody gets killed, he would be responsible. If he did, now since he didn't put the CE mark on it, he put some other China export mark, then he's not stating his responsibility anymore. But he is acting against the law, because he's putting this power supply on the European market without a CE mark. Now, what about this producer? I mean, he is somewhere in Far East, in China, let's say, and we are buying it over eBay or AliExpress. What then? Well, if someone as a seller, as a reseller, is buying things from outside EU and selling inside the EU, it is his sole responsibility. So if I if I'm buying something and selling on Bauhaus somewhere or some web store here, then it's my responsibility to check for the conformity of the product and the CE mark. If that's not the case, then I am the one who will be responsible and charged. And since I'm breaking the law, that means not just the payment fee, the fee, but also jail. Quality marks are something completely different. They are not the passport for EU market. They're just telling how good the product is, nothing else. And here you can read all the comparison I've been more or less talking about. In other regions, we have other regulators, like in USA, you have UL or FCC, FDA for food, Russia, Australia, and China as well. So each region now has its own, passport mark for the goods to be able to be on that market. How you get to the CE mark? It's a 6-step procedure, and you should start here. You are producing or you are developing a new product. You should identify all directives and harmonized standards for that product. Then you should verify the requirements in the standards. Then you should identify whether it's you that you can assess the conformity or you need a notified body to do it for you. Depends on how is the risk level of that product. Then you should test the conformity and draw all the documentation, everything, all the technical documentation, and then you should affix the CE mark and write the declaration of conformity. Usually it's just the way around. First you sell the products, you put the CE mark on them, and then if inspector comes to you, then you start thinking about all the rest. And when does the inspector come? That's also maybe a good question. Inspector doesn't come by himself, more or less. Usually somebody calls and says, okay, there is a company selling something that is suspicious and they are my direct competitors. Check them out. And then the inspector is obligated to come and check. And then you have a problem. So if you have serious competitors, well, you bet they will send you someone to check it out if everything is okay. Technical documentation, well, what it should contain? I can say quite simply, everything, especially test reports. Test reports that are showing that your product is compliant, but also the rest. Technical documentation is something that everyone that with technical knowledge can come, take it and reproduce your product. It is a private document and you show it only to inspector if required. Declaration of conformity, on the other side, is a document that is available to everyone. It's online, free document, which just tells the basic data of the component of the product, as notified body number if it was tested by the notified body, and at the end the signature of the responsible people. It's not necessary that it's attached to the product. It could be in local language or in any global languages. And but that's the legal document that is stating the responsibility of the manufacturer for the conformity. This is how a declaration of conformity looks like. So it says, we blah blah blah, we declare that under the sole responsibility that this product, that one, is manufactured in accordance to the requirements and follows all the rules and is compliant with this standard and this and this and this and this and this. So we put the CE mark on it, and the notified body checking it was that one with this number. And these are two directors signing, and these are the one who will also be responsible if something goes wrong. So manufacturer responsibility is that it undertakes all the necessary measures that the product is compliant, and the manufacturing process then is controlled in a way that the product range is compliant when it's produced, and that is all the technical documentation there, and that it complies with all directives. So how to ensure compliance of product? That's a problem, because you are producing thousands of products, and how do you know that all are compliant? Because that's your responsibility. Well, we'll see. But you have to keep all the data, all the documents for 10 years after the last product was put on the market. 10 years after you sold or you made the last product. And if inspector comes, you have to take it from the shelf. Okay, here it is. All right, so how do we assure that all these products are actually compliant? That is shown in this picture. I'm sorry, some of the parts are in Slovene, but I think you will get it. Now, the manufacturer has two main ways. Either it goes for the standalone or for the combined ways. These are modules, CE mark testing modules. We have module A, G, and H, which are standalone modules. Then we have B, which is combined with C, D, E, or F. B is in the design phase, and these are in production phase. All right, let's go a little bit into details, and I hope that you will get it. So, let's start with the standalone modules. Module A means that producer, the manufacturer, has internal production control. So the manufacturer is the one that tests the conformity of the products. And this is only for really low risk products, because if there is even a slight chance that something will go wrong, then it is best for someone else to confirm the conformity, not the producer itself, because there is a slight problem with that. So, on the other hand, we have module G, which is unit verification module. What does it mean? Every single product you produce will be checked, tested thoroughly by a notified body. If this is a very low risk product, this is very high risk product and low quantities. The module G is called full quality assurance, which means that the manufacturing process is regularly checked by a notified body. So, notified body is not checking every product, but it is checking only the manufacturing process. So, individual products are not verified. But if the manufacturing process is certified, then this assures that products are also compliant. Now, what about the rest? Going to combined modules, which are I would say the most common. First, in the design phase, you produce a prototype. And this prototype is, checked several times. But just before it goes into production phase, it has to be confirmed. And this is called, let me be sure, EU type examination. Yes. EU type examination means that you are measuring all the characteristics necessary to confirm that this exact type of the product is compliant. So, when you are producing the same products as that one that was confirmed, if you don't change anything, that means that all the rest of the products you are producing later will be also compliant. So then when you get from design to production phase, you can choose from modules C, D, E, or F. Now, C means that the producer, the manufacturer, is also checking the production phase. So the production control is done by the manufacturer itself. Module D means that the production control is done by the notified body. Module E means that only final testing of the production at the end is certified by a national body, by a notified body. And module F means that every product is tested by a notified body. So going through these, I would say module B plus C would be a normal way to go. If you don't have low risk products, if you have medium risk, you better go with B plus D. But it also depends on the European directive, because some directives are requiring this scheme, others other, and you have to comply with them. So which module you are choosing, it depends on the European directive which you are checking for and the type of the product you are producing. Here is everything written that I just told you. Let me just show you the rapid alert system. That's a platform through which the inspectors are putting information about the withdrawn products which are dangerous or have other issues with the conformity. And by that, in the whole EU, you can recall the products back from the consumers or from the stores if they are dangerous. So, finally, the last slide of this lecture, showing which are the fields which are covered with the new approach directive. There are many, but the ones which are important for electrical engineers are electromagnetic compatibility, equipment for explosive atmospheres, low voltage devices, measuring instruments, medical devices, radio equipment, and restrictions of the use of certain hazardous substances. But there are others like toy safety, recreational, pyrotechnics, pressure equipment, and so on and so on. There are many. And what to tell? As I told at the beginning, there are many products sold in EU which do not require CE mark. Those who require CE mark are shown here. So what is at the end important for you to remember? You should know the international and EU standardization organization, recognize their symbols and what they are covering, which field they are covering. I'm talking about ISO, EEC, ITU in international level, and European. I'm talking about CEN, CNELIC, and ETSI. You should be able to explain the meaning and methods of this new approach. What is it about? What was the reason for the new approach in EU in 1985? Explain the CE mark importance. What is the meaning of the CE mark? And which are the ways to ensure the conformity to the CE marking? So these modules A, B, C, D, E, F, G, H. You should know what is the necessary documentation for the CE marking and what is the content of that documentation, and explain the essence of these EU directives, which will follow now. Here there are some links which you can read and check if you want to know more.